Great. So what I will be covering today, for those of you who are in my master's class, I think I've already covered this for you, so it would just be a repeat of that. But for the other guys who are joining the class, obviously it's going to be new. So what I want to do is to open up the concept of K nearest neighbor, okay, which is one of the most commonly used and simple to understand and also widely used classification algorithms, although it is also used for what you say, regression, but our focus is going to be for the classification. Yeah. Just to be on the safe side, can you just confirm? You can just put a thumb up that you can see my screen and you can hear what I'm saying. Just one person confirming it would be okay. Excellent. That's perfect. All right. So the idea of classification. This is the example that I always use, and I think it's really nice and easy to sort of remember. Okay. So imagine we are at a car dealership, like a Ford's car dealership, and we have customers who come in, they have a certain age, they have a certain salary, and we know that whether this guy who comes to our sort of dealership buys the car or sorry, buys the car or basically doesn't buy the car. And we want to see if K nearest neighbor can sort of do this job for us so that as soon as a customer walks in, if we know their salary and their age, this is just hypothetical, yeah, we can sort of predict, okay, he's going to be a time waster, or no, he's going to actually buy a 30,000 pound car from us, all right? Obviously, we're going to be having some old data, just like all supervised machine learning models. It means we need to have a certain set of previous data that we're going to train our model with, yeah? So shall we go and say, I'm going to just put, like, let's say these are, yeah, red. So these red circles are going to be customers. Well, that's not a red circle. What happened? Yeah, these red ones are customers who basically come in and waste our time and don't buy a car, okay? In other words, they take the time of our sales associates. And let's say these blue ones, okay, are the customers that come in basically and have a chat with us, and they sort of end up spending 30, 40K on a new car. Well, I don't know how much new cars are these days, but yeah. And then we are quite satisfied with that. Let's say this is our historic data, okay? Now the K nearest neighbor model works on the algorithm is quite simple when I say it. So I'm going to just play the game on the piece of paper that we assume here. Yeah. So let's say we have this data on a sheet of paper. We are sitting in this car dealership, and then we got Mr. Customer Green comes in, and we take his salary and age, and we plot him in our little plot here. And we are sitting there discussing, okay, is he going to buy the car? Yeah, so buy or time waster. Well, that's not a nice way to talk about customers, yeah. Well, for the sake of our lecture and argument, we say, yeah. So is this guy a time waster like the red ones, or is he going to purchase a car like the blue ones? So if we make this decision, how much time do we want to spend with him? Shall we just tell him, okay, mate, go and, have a look at the cars, if we think that he doesn't want to buy the car, or should we sit down, make him a cup of coffee, play nice, be good and all that, and spend some time, like getting one of our associates to spend time with them. And that's what we want to do. Now, the idea of KNN, or K nearest neighbor, is that we are going to say, well, let's look at the neighborhood of this new customer and compare it with our existing data. Obviously, this scatter I've done here is quite simple, yeah, and that's for the sake of trying to get the idea introduced to those of you who this is completely new, yeah. So I would come and suggest as one of the team, I'm going to say, all right, guys, how about this, yeah? Shall we decide to look at the 3 nearest neighbors of this, yeah? I'm going to say, let's pick 3 nearest neighbors, yeah, of this new guy who just walked in. All right, so who are these 3 neighbors? We're gonna, for example, say him, him, and maybe him or her. I don't know. Whatever. We have just assumed that these 3 are the nearest ones. So because how do we choose number 3? Well, I just came up with it. Somebody could have had said 5. Somebody could have had said 6, 7. But we just come up with the number 3. Okay, so we all agree on the 3 nearest ones, and we look at these and we're like, okay, so in its vicinity as neighbors, from 3, we got 2 which are sort of potential, have been buyers, and 1 who has been a time waster. So, just based on this, I mean, like we're playing this game in our car dealership, we're going to say, yeah, yes, the guy is going to buy the car. Yeah, we're going to decide that. Then we got another customer walking, let's say, give him a purple color maybe. And this customer is going to be, you know, standing somewhere here. Right away, we follow a rule and we say the 3 neighbors are that and that and that. Well, considering that the majority of its neighbors were time wasters, so no, he ain't gonna buy a car, okay? And the 3rd customer comes in, let's say give him a yellow one. I don't know if yellow appears here. And the yellow guy comes and falls here. We choose the nearest neighbors. We say, okay, this one, maybe this one, and majority fall in the buyer section because of the 3. And we're going to say, well, cool. We are going to say that this guy is a buyer as well. Yes, well done. You know, like, so let's spend some time on it. Obviously, if instead of number 3, we had chosen number 5, you can appreciate that depending on how your training data, meaning your previous data, has been scattered, then your predictions would be different. Especially, for example, in this model, if instead of 3, we wanted to have more nearest neighbors to sort of evaluate that with. Yeah, but we're gonna just stick with 3 for the moment. That, at its core, is what this whole KNN is all about. Okay, so KNN, if I want to put it in its simplest way of somebody understanding it, that's all it is. Okay. Now, obviously, this was a 2-dimensional data, yeah. But if I had like another parameter, for example, we have this. Let's say we had age and salary, and we had sex or gender, okay. Then we're gonna have a 3-dimensional sort of a space, which is still we are able to visualize, but obviously less easier than that, yeah? What if we have more dimensions like age, sex, salary, and maybe, I don't know, like level of professionality, yeah? Like, or maybe whether they're British citizen or not, or whether they, I don't know, their height is something, whatever parameter that you can think. Then we're going into a 4D space, and then once we go into 4D, it's not even possible to visualize it, yeah? Because as humans, we can only visualize it, you know, in 3 dimensions and maximum, you know, and once it goes into 4D, everything we talked so far goes into the mathematical sort of form, yeah? But the principle is the same thing. So what I want to do is to get to a start easy. I'm going to introduce this idea with you this week by using just imagining this 2D space and a very simple sort of approach. Yeah. So forget about 3D. Yeah. Forget about 4D, 5D, 6D, whatever. We're just going to say that we got the customer's age and salary. How can we write the algorithm for this? Okay. Once this sinks in and you understand it, okay, that should be enough, okay, for you to understand what KNN is. Because then we would use scikit-learn and do this like pretty easy, okay? But there is no point in you learning how to do this in scikit-learn if you don't really have a clue what the algorithm is all about. But that's what this is, okay? So now we are going to pretend like exactly what we did here on a sheet of paper. We're going to try to do it in Python, okay? So that's what today's lecture is going to be, and I'm not going to make it much complicated, but then we will pick up more on it, from next week or in the next session of lectures. So if I put this down, and you can code along with me, or if you just want to look, you can look. I've already written this code actually. Yeah, I've had it prepared from before for one of my lectures. So I can either copy paste or let me do some of the copy paste because I want to finish early as well. So I'm just going to import two libraries. First of all, I want to introduce you to this counter, from collections. So from the collections library, I'm importing counter. What does counter do? Okay, it's important for you to first understand this before we go to the KNN. Okay, so if I come and say, let me just, okay, so let's say I have this list, yeah? So I have a list of fruits, yeah? In this list, I have apple, banana, apple, orange, banana, apple, okay? What counter enables me to do is to look at the list. Obviously, this is a list that when you look with naked eye, you can quickly say, okay, I have 3 apples, I got a couple of bananas, and I got 1 orange, okay? So you don't really need counter for you to to tell you this, but obviously we want to know what the functionality of it is. Yeah. So if I come and say fruit counts, yeah, fruit counts equals counter, and I'm going to feed to counter my list. Okay. Okay, fruit counts equals counter. So I imported this function from this library, yeah. And I have a list. I called the function and I fed into the function as an argument my list. That's what I did, yeah. So now I have something called fruit counts. Let's see what is this fruit counts all about. Fruit counts. Okay. So if you notice, fruit counts is basically a dictionary, okay? So it generates a dictionary where the keys are items in the list, and the value is the number of those items we have in the list. So that's what counter does for you, okay? So you can imagine if you have a massive list of, let's say, 10,000 different things, yeah? Obviously, then you cannot sit down and with naked eye look into sort of counting this thing. All you need to do is to use the counter, feed your list into it, and it would classify them, classify them in form of a dictionary by using the name of your items, yeah, by using the name of your items as the keys and the number of that item being repeated as the value associated with that key. So that's what this counter thing does, all right? And it's important that we understand it. Now, once we have this, okay, we can use the most common function. So if I come and say fruit counts, okay, dot most common, there you go, it comes up. That's what I love about Google Colab. When you do this in Jupyter, you don't have that luxury. of this thing filling it for you. So if I say most common, now what did most common pass back to me? It gave me a list of tuples, yeah? A list of tuples, which is basically the same dictionary coming out, but this time in form of a tuple, okay? And why would I want to use this? Because it enables me to play about with the, what do you call it? With the numerical structure of my data, okay? That's what enables me to do. So if I come and say most common 1, when I put 1 here, it means give me the most common only, okay? That's what number 1 means. So if I come and say, if I repeat this thing, if I like put number 2, it gives me the 2 common ones. And if I put 3, it's going to give me the 3 common ones. Obviously here we have only apple, banana, and orange. So we have 3 different things. So really there is no point for me going and saying, you know, give me the top 4, because it's ridiculous. Like, I don't have 4, yeah? But 4 different items. But ideally that's what you do, okay? That's what you do. So let me get rid of that nonsense. So I hope you understood what does most common also do for us, yeah? We are going to need this later, basically, for this understanding the KNN structure, right? And of course, we can do, I'm sure, like, you know, tuple unpacking, yeah, but just as a reminder, fruit counts, dot most common, and if I say 1, so the most common, the most common one only, if I put 0, I hope that you're saying that I'm going to get the apple. Yeah. And if I do, so remember how this is going and picking that up. Yes, yeah, so I'm doing most common, gives me the list with 1 item in it, because give me the most common only. And then 0 picks out the first element in this list, which is the tuple. So if I put another 0 here, obviously I hope you understand that now it's going to just pick the word apple for me. It's really important you understand this counter and these functions. These have nothing to do with KNN itself, but it's important that you understand this so later on you don't get confused, yeah? So when you revise this video, like, that's what you need to do, sort of, yeah? You need to basically make sure that you have understood this, okay? All right, now let's go and make our simple example, yeah? And here I'm going to copy paste just for the sake of saving time. All right, so let me do this. All right, and I give you some time for those of you who are coding. So let's say that's my data, okay? And I've imported NumPy, haven't I? Yeah. Oh yeah, if I didn't, this would have given me an error. So I have my X train, okay? So I have my X train, which is my training data, right? We're just gonna pretend that, you know, when we were playing with that game, customer age and salary, we're gonna assume these first ones, yeah, are the customer age. Yeah, we have a customer who is 1 year old, 8 years old, 3 years old, 6 years old, 7 year old, and 2 year old. Just playing the game. And their salary is £2, £8, £3, £5, £6, £8, and £3. Okay, just a game. And these customers have been visiting our dealership before. Whether they have bought a car or they haven't bought the car, we have a Y train. Okay, so this is indicating whether they bought the car or they did not buy the car. So how many items we have here? How many customers we have? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 6 outcomes. So this customer, 1, 2, the 1 year old with £2 salary, didn't buy the car. The 8 year old with £8 salary bought the car. The 3 year old with £3 salary didn't buy the car. And the 6-year-old with £5 salary bought the car, 7-year-old with £8 salary bought the car, and the 2-year-old with £3 salary didn't buy the car. So we're just going to assume this super simple data is what we have obtained in this dealership based on our past sort of experience. Yeah. Okay. Now, quickly, I'd like you to always sort of do that, stuff that we check. So X-train, always, like I'd like you to do this whenever you get into this machine learning sort of idea. When you get large data sets, always just take the shape, see what's happening. It gives you some indications. Okay, so you have 6 rows, 2 columns. Obviously, we've seen it here, but as a good practice, you do this. Let's make now our imaginary customers. Yeah, so let's make our imaginary customers who walk into the shop. Okay, so we're going to say Mr. and Mrs. X, 2 separate customers, and I'm going to just use this. So these are our imaginary customers. Yeah. Let me just put it here. Our imaginary customers. Okay, there's 2 of them basically. These are the guys who are going to be basically walking into the shop, and based on these previous data, we want to find that, are they going to buy the car or are they going to waste our time, basically. Yeah. Now, let's have some conditional selection. I hope you remember these stuff. So I'm going to say X train. If I say X train, and in the bracket, I'll put a condition, which is Y train, okay, equals 1. All right, guys? I hope you're all familiar with this. So if I run this, what do I get? So here I have my training data with a bracket and the condition within it. Okay, which basically which basically goes and fetches all the points associated with customers buying the car. Okay, so this is fetching out the data points relating to customers who bought the car. Okay, and obviously if I put y train equals 0, yeah, then it's going to fetch those that didn't buy the car. So we can just practice that as well. Yeah, so these are the customers who didn't buy the car. Now the cool thing about this, of course, is that if we go and we can actually go and pick out each column separately. So if I come and repeat this code, so now if I put comma 0, okay, I should be getting 867. Okay, so let's see if I get that. 867. It just went and picked the first one. That's because I put a 0 in there, meaning just the first column. And if I put 1 here, obviously it's going to pick out the second column, right? So once again, not necessarily anything to do with KNN, but it's important that you know what these means, so when we go to build the algorithm, okay? Now, what time is it now? Okay, 18:40. So I'll try to wrap it up in 20 minutes, hopefully. Okay, so we learned some tools. Well, we knew these before. Maybe this one was the new one. Okay. Fair enough. Now we have our tools and we have our data. What do we do first? A good data scientist always visualize your data first. Okay, so Obviously, our simple data, we have made it ourselves. This is all made up, but we're going to assume that this is, you know, the data that BMW or Ford has gathered over 5-6 years, and we want to see how does this work. Yeah. So I'm going to copy paste, but I'm going to go step by step so you don't miss out. So we're going to obviously, you know, like to plot, we're going to use matplotlib. So I'm going to import matplotlib dot pyplot as plt. Okay, so that's our library for plotting, and I'm going to do, let me do it bit by bit. I'm going to start with this. Okay, so guys, please pay attention. plt.scatter, plt.scatter. What do I want to scan? What do I want to plot? Do you remember this plot, guys, we have? Yeah, this. So let me get rid of all that nonsense over there. Yeah, and forget about these things. Okay, so at the moment, we just want to plot basically your customers. Yeah, we want to plot age and salary. That's all we want to do, right? So because our data is in the form of, you know, we have these sort of vectors, okay? So what we want to do is technically we want to plot 1 against 2. It would be a dot. 8 against 8, 3 against 3, 6 against 5, 7 against 8, 2 against 3, okay? And I've shown you here how you pick each of these up. So I'm going to say plt.scatter just as a reminder. A scatter does, you know, plot of 2 points against each other. So I'm doing plt.scatter, and maybe if I just show you first this simple one. Okay, so plt.scatter, x train condition equals 0, x train, well, y train equals 0, 1. What did I show you here, guys? Look, x train condition equals 1, both it 0, and x train, so this is what I'm showing you, yeah? So that and that. All I'm doing, I'm plotting these against each other, okay? All I'm doing in this picture, in this code, I'm plotting, well, I'll put 0 here, but sorry. So this is like those who didn't buy the car, yeah? Did not buy, okay? So if I do that, look, that's what I'm getting, right? Because if you notice, it's just plotting 1 against 2, okay? 1 against 2. Then I have 3 against 3, this one, and 2 against 3. 2, what is it? Oh, sorry. Yeah, 3 against 3, which is that last one, and 2 against 3, which is that. Okay, so that's all I'm doing here, guys, yeah? But let me get rid of that, but we need to make it nicer. So I'm going to, so far I just explained that to you. Color B, these are, for example, not buyers, yeah? And let's put that, these are not buyers, yeah? Let's put these red, and let this put this B, okay? So blues are buyers, and the reds are not non-buyers. So if I run this, that's it. I'm getting this plot, yeah? Exactly similar what I just showed in this, yeah? So just we are mimicking that concept. All right? Except that we want to make this look a bit nicer, okay? So I'm going to add some decorators to it. We have covered these before, so I won't spend too much time explaining it, except that I would just say plt.scatter xtest xtest color, okay, label ytest. Remember, what is this ytest? So this is for 2 customers who just walked in, and these 2 are our previous customers, and if they buy or not buy car. Yeah. So that's our training data. This is our test data. So if I go and do this as well, now the color here I used red, I used blue, but this is just to also add a flavor and also let you know that you can choose the colors by giving the RGB coordinates if you like. Otherwise, you could put this Y for yellow if you wanted. But this is just showing you basically, how you can modify the color. I think I've covered this before, but anyway, these are simple stuff. Cool. Now let's make our visualization more professional. We're gonna add title. Always, 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 when you visualize, it's important that you indicate what is your y-axis, what is your x-axis, and we're going to just use plt.title, plt.x-label, and plt.y-label. And once we do that, so we're going to add that, okay? And it's going to give us basically this axis of our plot, yeah? And finally, to have better sense, we can add grids to it. So just plt grid and plt.legend to have, so plt. Let me just take legend out for a second. So plt.grid adds the grids, and plt.legend, when I activate it, it's going to tell us, basically who is a buyer, who is a not buyer, and all that, yeah? These keys. So reds are non-buyers, blues are buyers, and we have these two customers that we need to figure out if they are time wasters or if they are buyers. Obviously, I've put this data so that it's going to be simple to understand, yeah? Now, the whole idea is, how on earth are we going to do that? Yeah, so in the previous example, here I said that when we get a new point, like this point, okay, we're going to be measuring the distance, the nearest ones. Yeah, but how do you measure the near one? Well, it has to be this point, isn't it? Now, this is very important for you to understand, because if you don't understand it, everything collapses. So let's go now into the idea of measuring the distance between 2 points, okay? So let's say this is our x-coordinate. Forget about all this example for a moment. Let's just go back to something else. I'll give you a plot of 2 points, okay? So that's point 1 and that's point 2, okay? What's the closest distance? Well, how far are they from each other? Well, you need to draw a straight line, which is the closest distance between these two. Okay? So that's the closest distance between point A. Okay, so if you call that A, and if you call that B, that's the closest distance. And we also refer to it as the Euclidean distance. Okay? But how do we measure this? Well, obviously we need to have the coordinates. Once we have the coordinates, guys, yeah, let's think about it. We can convert this into a triangle, all right? Not convert it, but draw a triangle out of it, okay? So there we go. Can we call this thing ABC, isn't it? C, point C. Okay, so we want to know what is AB. Well, AB is, from Pythagoras, AB squared equals AC squared plus BC squared. Okay, I'm sure all of you are familiar with this. Well, I hope you are. Okay, so how do we measure AB? Basically, it's going to be the square root of, let me do this. So if we want to measure AB, all we need to do is to get a square root of this whole thing, yeah? Square root of this, okay? And that, I need to get rid of this AB squared. So AB would be the square root of adding these two squares, yeah? This is Pythagoras. We get the AB. So that's exactly what we need to do in our algorithm, okay? To find the distance, when you want to find the distance between this point and that point, and basically all the points, we literally need to write a function that goes and uses this relationship and measures the distance of our newcomer customers to each of the existing points, okay? That way, it can find the nearest neighbors, whichever like finds the minimum top three distances of this, yeah? All right, and how do we do that? Well, let me copy paste this for you. Don't worry about what this, the code part of this thing, yeah? I just want you to look at the formula. Ignore all that gibberish, like forget it. Just look at this, yeah? This is technically everything we just spoke now, yeah? So, do you see this P here? Just consider that P to be 2 for the moment. This is called Minkowski distance formula, okay? But depending on what you put for P, the way it calculates it is going to be different. If you put 2 instead of P, it's going to be what I just explained to you, okay? So what I explained here is just, to the power of 2, wasn't it? Yeah, square root and all that. So just stick to that P being number 2. You don't need to think about using P equals 1 or 3 or 4 or anything, yeah? For the moment, we're going to stick with P equals 2, which is going to be the Euclidean distance, yeah? How do we write this, guys? How are we going to write this function? So, remember, if I again go back to, where did we go? All right. So, point A, this point A is going to have coordinates, isn't it? At the moment, we are having coordinates. So, for example, it is, let's say, I don't know, like this is 2, and this is, let's say 3. So this is A is 2 comma 3, and B is, I'm going to be imaginative now, yeah? B is going to be, let's say 6 and 6 and, for example, 6. So that's the coordinate. So A is 2 comma 3, and B is going to be 6 comma 6. Okay, that's the idea. My apologies. Okay, so what is AC and BC? I want you to think about it. So A is 2 comma 3, B is 6 comma 6. We know this Pythagoras relationship. We know that we need to get AC square root. We need to have BC and square root. How do we get these? Look at that. If you subtract 2 from 6, meaning B minus A technically, and 6 minus 3, it would give you these distances. Okay? I hope if this doesn't make sense, watch it again and try to make sense of it. Yeah? So we are going to subtract the coordinates from each other. And that's what we're going to do to get AC and BC. Rest is just some algebra. A square root of these values squared. So let's put this in Python, okay? And we're going to say that that P, that I explained to you, is going to be 2, okay? So we just stick into Euclidean distance, nothing complicated. Where did my code go? Okay, yeah, all right. So we're gonna just run this formula, all right. So I'm going to define that Minkowski's distance, and it's going to be this, yeah. So I'm defining a function. You can call this function Mickey Mouse, as I always say, but obviously that's a silly name. So we're gonna just call it Minkowski distance. Point 1, point 2, P equals 2. As I said, we're just gonna stick to 2, like in the example I told you. Return NP, sum of NP absolute values of point 1 minus 0.2. So that's our function. That's our function to just find the distance of 1 point. Okay. So still, we are nowhere near KNN or anything like that. We just wrote a function that is capable of taking 2-point coordinates and telling us the distance between these two. Okay? That's all we've done so far. So if I look at our X test, for example, or X test 2, 2, 6, 7, okay? What I can do is, let's say I want to use the Minkowski function and that we created and find the sort of distance between this first one and another point which is 3.3. Okay, so I'm going to use the Minkowski function. Minkowski distance. Yeah, that's our function that we just created. And I'm going to say, for example, np.array 2, 2, which is that point, in our X test. This is example, guys. Yeah, so you just see that our function is working, right? np.array, and we're going to say 3, 3. All right. So technically, it's like as if I have this 3.3 and I have this 2.2. So I want to find this distance, guys. Yeah. What is the distance here? I hope all of you are saying, well, Ali, we can see this. 3 minus 2 is 1. And 3 minus 2 here again is 1. So it's a square root of 1 squared plus 1 squared. But 1 squared is 1. So a square root of 2. I hope all of you are straight away saying that to me. But then if you're tired and you're like, oh, really? Well, that's what it's going to calculate. It's going to exactly calculate this distance. Yeah, so let's see what do we get. So if I run this, I'm going to get an error. Cannot construct a type from an array. What did I do wrong? Yeah. Silly me. I do apologize. Okay, so yeah, 1.4142. You might be asking me, is that centimeter or meter? Well, it depends on the unit, whatever unit we have in there. We don't need to worry about that. They're all going to be within the same unit, isn't it? So that's the distance. Yeah. And shall we say that that's for sure? You know, like definitely. Well, you can calculate it using a calculator later on. So that's what we just did. And I've written this code here just for further elaboration. I'm not going to like go over this code much. You should know it. Yeah. That's it. We just measured this red distance. That's going to be 1.414. So definitely your function is working. Okay. So now that we know our function is working, we can go into, well, you might be, let me just do this as well, because you might be like, oh, how do we know it's working? np dot square root of 1 squared plus 1 squared. I haven't made a mistake, have I? Hopefully not. Yeah, there we go. So one basically. So it's definitely your function is working. All right, and we measured it. Now we're going to actually, so let's see the KNN algo. Okay. All right. I'm going to copy paste this and then I'm going to walk through it with you. Yeah, I've written it here. Okay, so this is going to be our KNN algorithm. Let's see what does it do. So our algorithm is a function. Okay, so define KNN. We name it KNN. Yeah. It's going to take an X train or training data. It's going to take a Y train, which is our outcomes. You know, customer bought the car or didn't bought the car. It's going to take our X test. Yeah, it's going to take our X test, the customers who just walked in. it's going to take that k equals 3. You know, like when I said we chose in our game to choose the 3 nearest neighbors, isn't it? And for that Minkowski, we're going to define a p, and I said we're going to just stick to p equals to 2. Yeah, simple as that. We're going to set p equals to 2. So we initialize our function. It's going to take our x train, y train, or x test, and k equals 3. It's going to pick 3 nearest neighbors, and p equals 2 for the Minkowski distance formula. I then create an empty list that I will update. Yeah, so here I forgot to put a comment. Creating an empty list to update it with my preds. Okay. Now, then I start a for loop, because technically speaking, what I want to do, why am I doing a for loop? So this new point comes in. Please listen carefully to this, yeah? So this, I wanted to get rid of this and I got rid of those. Let's just get rid of that. So I want to, let's say if this is my point, yeah? I want to run a for loop. Measure the distance between this point and every single other point in this plot. Every single other one, yeah? That, I'm feeling lazy to do all of them, of course, yeah? So I want to draw a for loop, and I want to say, sorry. And I want to say, look, just go and measure this distance, you know, the way that we measured it before, with every single other point in that plot. Yeah? And that's what this piece of code is doing for me. Look, my predictions are empty. For test point in X test, distances equals Minkowski distance. We already run the Minkowski distance under a for loop. Test point, X train, comma P. Okay? With Minkowski, what do we give it? We had a P which is already set at 2.1, 0.2. So it's looping through, picking every point coordinate and measuring that distance. Yeah? So I've put this in a list comprehension format. Yeah? If you like, you can practice writing this using a basic for loop. All right? It's up to you. But for making it short, I did it like this. So for X train, next train, basically just go and find that distance. Print distance, okay? Now, K indices, np.arcsort distances, okay? Look at the distances. So I found this, when it goes there, it measures for test point in X test. Listen carefully. For test point in X test, how many X test data do we have? 2 of them. It was 2, wasn't it? Yeah. So first it goes with this one, measures the distance of that point with every other point, picks this, and picks this one, 2.2. Measures the distance of this with every single other point that is here. Not this other green one, because that's a test as well. Then it becomes, and saves it, names it distances, okay? But what do I do with k distances? I say k distances equal np.arcsort the distances up to k, meaning give me the three all the way to 3, the 3 nearest ones, yeah? Okay? Please pay attention to this. So this distance for every point in our test point, well, we have 2 points. Let's consider we are on the first round, the first one, 2.2. It goes and measures the distance of that with every other point in there, okay? And it's a list. It gives us a list of distance of point, which is 2,2, with every other point in there. Then k indices, I've named it k indices, you can name it Mickey Mouse, equals np.arcsort, arcsorts the output of this and picks out the top 3, the closest ones, yeah? Meaning the shortest distances. okay, and picks that out, the indices of those closest points, yeah? And then k nearest labels, okay, we found these points, so our algorithm, it basically went there, found the nearest, these are the nearest three. So it found the distance between all of them, yeah, all the reds, all the blues, but using arg sort and limiting it to k, which is 3, it will only have these three. Okay, so it knows the distances of these trees, but what are their labels? Because these data had a label associated with them, which was the y-test. And then, in this part of the code, k nearest label equals y-train I, y-train I, for I in k indices. Look, this I, y-train I, we are picking the index of those, yeah, index of those nearest points and associating it with their labels. Okay, so we are picking up the labels of those. Now, do you remember most common equals counter? Yeah. Now, here is when I said that you need to make sure that you first understand this bit. Yeah. Sorry, my apologies. Oh, my throat is killing me. That's why you need to understand this counter now, so that you understand what is happening from this point onward. So that hence why I want you to fully understand this, then move onward. Yeah. So what did this do? It picks out the closest ones, the most common ones. Yeah. So in this bit, most common equals counter k nearest labels and picks out the most common, and then print most common predictions, which is that, dot append most common bracket 0 0. Again, I covered this bracket 0 0. That's why I was trying to tell you what this is. So we are picking that particular label. So please make sure you understand this fully, then you go into this. Otherwise, if you don't understand it, by the time you get here, you go completely confused. And don't try to like say that, oh, I need to understand this the first round. Watch the video multiple times, code it yourself, practice with it. So I'm going to now run this. Now we have our k nearest neighbor algorithm basically ready, okay? And if I say, we're going to just say k equals, I've written this before. I've exceeded the time I wanted to spend on this, but anyway. So k equals 3, p equals 2, predictions equals KNN. We are creating a predictions, yeah? Just remember, guys, this prediction, maybe I shouldn't have had named predictions. Let's just say preds, maybe. So you guys don't get it confused with the... Okay, is that fine? Yeah. There we go. So this preds had nothing to do with that, yes, so don't get confused. Okay, so preds equals KNN, X-train, Y-train, K-test, and it has gone and measured the distances, the K indices, K labels, most common, 0, 3, and so on and so forth, yeah? So this was the simplest form of trying to sort of get you to understand what KNN does. Obviously, when you go to use this algorithm, you will not be using any of this. Yeah, next week I will show you how to do it with scikit-learn, which is easy, okay, much easier. But I wanted to go through this so you understand what happens under the bonnet. And also it's a good Python practice, isn't it? Sort of, you learn more stuff and you become more familiar with the logic. Otherwise, when we use the scikit-learn, it's going to be much easier. You don't need to know to do all of that, but it's good that you know what's happening under the bonnet for the next video. That's about it. So please try to make sure you understand this concept. So next week, because technically speaking, for the other classification algorithms as well, if you have understood this, it makes you understand everything else much easier as well. So please, I wanted to keep this shorter, but it doesn't matter. As long as you go and practice and you fully become familiar with this code, that should be okay. All right, so let's end it now. And I do apologize if I exceeded the time. I wanted myself to finish it earlier, but then I had to go. So please run this, practice it yourself, and try to make sure that it makes sense to you, okay? And you're comfortable with it until next session. Uh, that's about it, guys. So I guess I'll see you next week, hopefully. Yeah. And if you don't have any questions, which I hope you don't have any questions, then I'm going to say goodbye. So a quick one, no questions? Good. All right. Have a good night, guys. Thank you for your time and thank you for your interest. Honestly, your interest gives me a lot of motivation for this. By the way, I'm uploading these now to a YouTube channel because it makes life easier for me that way. Also, it's more accessible compared to the other ones that many of you were constantly sending me emails saying you had an error with accessing the video and I had to go and, play back with it. But with the YouTube, it's going to be much simpler. So I will upload them there and I'll send you the link. You can just watch it anytime, anywhere. Not sort of restricted by the, complications of the other one. All right, take care, guys, and have a good night.